Hi, my name is Sherhoz Ahmed, and in this video we are going to cover a topic of IB Maths higher level. So the topic that we are going to cover is the logarithmic laws and solving equations. So first of all, let's go through the concepts part, and then we'll move on to the exam-related questions. So let's start off with exponents and logarithms. So in the exponents and logarithm, let's discuss a rule. So let's suppose we have a to the power of x equals to b, and we want to work out the value of a. So the value of a will be equal to log to the base of a of b. For example, if we want to work out the value of 2 to the power of x equals to 16, so we will convert this equation into the logarithmic form, and then from there onwards we'll work out the value of x. So it will become x equals to log to the base of 2 of 16. Now what you have to do is you have to check for how many times you have to read the table of 2 in order to get to the 16. So 2 to the power of how much is 16? So 2 to the power of 4 is 16. So like 2 times 2 times 2 times 2. So 4 will be your answer. X will become equal to 4. Let's do it once again. So let's suppose we have a question. 4 to the power of x equals to 64. So x will become equal to log to the base of 4 of 64. Now 4 to the power of how much is 64? So it's 4 to the power of 3 is 64, because 4 times 4 times 4 gives us 64. So x will become equal to 3. So 4 to the power of 3 will give us 64. So this is how we can use our exponents and logarithmic equations to work out the value of the unknown variable. So now let's move on to some of the laws of logarithms. Okay, so let's start off with the first rule. So if we have a log, let's suppose log to the base of c of a plus log to the base of c of b. So if two logs with the same base are being added, then in order to write them in the form of a single log, we can write it as log c of ab. And rule number 2. Rule number 2 says that if two logs are subtracted, then in order to write that into the single log, we can write it as log c of a over b. And the third rule says that if we have log to the base of c, a to the power of r, then this r that is in the exponent of a, that will be multiplied with the log. So it will become r log c of a. So these are three major rules for the logarithms. Now let's discuss another rule where we have to change the base of the log. So let me just erase it. Alright, so let's suppose we have a log to the base of a is of b. Now we want to change the base of this log with some other base. Let's suppose some other base is c. So in order to change it, we can write it as log to the base of c of b, like this number, divided by log to the base of c of this number. So this is how we can change the base of the log, and then we can just do our working and solve it. For example, if we have a question log to the base of 3 of 64, and we want to change it with base 2, so I can write it as log 2 of 64 divided by log 2 of 3. So in this way we can change the base of the log. So this was it for the concept part and the formula part as far as the logarithmic laws and solving equations are concerned. Now we will discuss some of the exam-related questions that are related to the logarithms. So let's move on to that. Alright, so here we have a simple exam-related question. It says find the value of each of the following. Give your answer as an integer. So part A, it says we have to work out log 6 of 6. So in order to work it out, we have to see 6 to the power of how much is 6. So 6 to the power of 1 is 6. So 1 is our answer. simple. Now let's see for this one. So in this one it says log 6 of 9 plus log 6 of 4. So we'll apply the rule where the logs are being added, so we can write them into the single log. So that would be equal to log 6 of 9 times 4. That will be equal to log 6 of 36. Now 6 to the power of how much is 36? So 6 square is 36. So 6 times 6 is 36. So our answer is 2, because 6 to the power of 2 is 36. So the answer for this one will be 2. Now let's see for this one. We will apply the rule for subtracting the logarithm. So we can write that into a single log as log 6 of 72 divided by 2. So that will be equal to log 6 of 36 again. So 6 to the power of how much is 36? It's 2. So 2 is the answer. So it's that much simple. Alright, now let's move to the next one. Alright, so here we have an interesting question. This question says consider b is equal to log 80 of 81 times log 79 of 81 times log 78 of 79 times up to so on up till log to the base of 3 of 4. And b belongs to the integers, and we have to work out the value of b. So you see over here all the logs have different base. So what we do is we will make the bases of all the logs to be same. So what I'll do is I'll make the basis of all the log to be 10. Alright, so or anything like any base. I will make the base of all the logs to be, let's suppose so I think 10 is fine. So my b will be equal to log 10 of this number, that is 81, divided by log 10 of this number, that is 80, times log 10 of this number divided by log 10 of 79 times log 10 of 79 divided by log 10 of 78 up to so on. Then we will have at the end log 10 of 4 divided by log 10 of 3. So what will happen? This will get cancelled with this one, this will get cancelled with this one, and this is how the sequence will go. This log 10 of 78 will cancel with something from here, and the denominator of log 10 of 4 will get cancelled with this numerator log 10 of 4. So at the end we'll be left with log 10 of 81 divided by log 10 of 3. So we can write 81 as 3 to the power of something. So it'll be like log 10 of 3 to the power of 4 is 81, because 3 times 3 times 3 times 3 is 81, divided by log 10 of 3. So it'll become 4 log 10 of 3 divided by log 10 of 3. So we'll cancel these two, log 10 of 3, and then we'll get the answer of b equals to 4. So this is how we'll change the base of the log and get to our answer. So this is it. Now let's move on to some medium level question. Alright, so here we have the next question. It says solve the equation 15 to the power of 4a equals to 81 to the power of a plus 2 for a. So basically we have to work out the value of a. So in order to represent it, we will write this as 15. We have to express the answer in terms of ln 3 and ln 5. So I'll break down 15 into 3 times 5 to the power of 4a, and I'll break down 81 into 3 to the power of 4. So it will be like 3 to the power of 4 to the power of a plus 2. Alright, so over here on the left side I'll have 3 to the power of 4a times 5 to the power of 4a, and on the right side I will have 3 to the power of, this is a, not 9, so it will be like 3 to the power of 4a plus 2. So it's like 3 to the power of 4a times 5 to the power of 4a equals to 3 to the power of 4a times, because the exponents are being added, so we can multiply the bases. So it's like 3 to the power of 4a times 3 to the power of 2. So we'll cancel these two and we will left with 5 to the power of 4a equals to 3 to the power of 2. Now because we have to represent the answer in ln3 and ln5, so what we do is we'll take ln on both sides. So ln of this number, ln of this number, and after this I'll apply the property of the log, that whatever is the exponent, it will come before the log. So on the left side I will have 4a ln5 equals to, on the right side I'll have this 2 will come over here, so it will be like 2 ln3. So my 4a will become equal to 2 ln3 over ln5, and I'll also shift this 4 on the right side, so it will be like 4 ln5. Now this 2 times 1, 2 times 2, so my a will become equal to ln3 over 2 ln5. So this will be my answer for a in terms of ln3 and ln5. So this is how you can apply the properties of the exponents and logarithms in order to solve such equations. Now let's move on to the question with some hard difficulty level. Alright, so let's move on to this question. It's a hard difficulty level question. So in this question it says the first three terms of a geometric sequence are ln x to the power of 9, ln x to the power of 3, and ln x, and we have to work out the common ratio. So it's quite simple. We'll just take two consecutive terms, we'll divide them, and we'll get the common ratio. So the common ratio will be equal to ln x to the power of 3 divided by ln x to the power of 9, and we'll apply the properties of the log. This 3 will come over here, this 9 will come before ln, so we will have 3 ln x equals to 9 ln x. Ln x will get cancelled, and 3 over 9 will give us 1 over 3 as the common ratio. Alright, so now the next part, it says solve sigma k equals to 1 to infinity of 3 to the power of 3 minus k ln x equals to 27. So from here we have to work out the value of x. So basically this seemed to be the nth term of the geometric sequence. So let's confirm it whether it's the nth term of the geometric sequence or not. We will have to use the formula for the nth term of the geometric sequence. So we have the common ratio, that is 1 over 3. So I'll write r equals to 1 over 3 over here, and I'll use the formula for the nth term for the geometric sequence. So the formula for the nth term is an equals to a1 times r to the power of n minus 1. So a1 is the first term, that is ln x to the power of 9. So it's ln x to the power of 9 times r is 1 over 3 to the power of n minus 1. So it's like n minus 1 over here. So we can transform this formula into this expression over here. So I can write it here. Now this ln x to the power of 9 will become, this 9 will come over here, and it will become 9 ln x times 3 to the power of 1 minus n, because when we'll flip it, the sign of the exponent will get inverted. So the exponent will become 1 minus n instead of n minus 1. Alright, now let's see how much can we solve it further. We want this expression. Alright, so now I'll just bring the working over here. So n will become equal to, I can write this 9 as 3 square, and I can write it as 3 times 3 to the power of 1 minus n, and this ln x as it is. Alright, so a of n will become equal to, now you see the bases are same, so we can add the exponents. So it will become 3 to the power of 2 plus 1 minus n ln x. So my an, the nth term, will become equal to 3 to the power of 3 minus n ln x. So as you can see, this expression, the nth term, is similar to this expression over here. Instead of n, we have k over here. So basically we have to add we have to add our nth term up to infinity. we have to find out the sum up till infinity basically. So we'll apply the formula for the sum to infinity on this nth term. So that will be equal to, and I'll put it equal to this term. So the sum to infinity is equal to a1 over 1 minus r, that is equal to this nth term, 3 to the power of 3 minus n ln x, and which is also equal to sigma, I'll write it as sigma 3 to the power of 3 minus k ln x, it's k equals to 1 to infinite. If I write it for this one, so I'll say it's n equals to 1 to infinite, because we are adding the number of terms up to infinity, and this whole thing is equal to 27. So from here we can say that a1 over 1 minus r is equal to 27. Alright, so I'll just remove all the working and I'll put a1 over 1 minus r equals to 27, and from there onwards I'll work out the value of x. Alright, so I'll write it here, a1 over 1 minus r equals to 27. So a1 is ln x to the power of 9, ln x to the power of 9, 1 minus r, that would be equal to 1 minus 1 over 3 equals to 27. So for this one I can write it as 9 ln x divided by 1 minus 1 over 3, that will be equal to 2 over 3 equals to 27. And I'll bring this 3 over here in the numerator, so it will become 3 times 9 ln x over 2 equals to 27. So 9 times 3 is 27, so it's like 27 ln x over 2 is equal to 27. So this 27 got cancelled, so I'll have ln x equals to 2. So now I'll take antilog on both sides, so it will be like x equals to e to the power of 2, because the base of ln is e, so x is equal to e square. So x equal to e square will be my answer for x. So this is how you will do the questions for the concepts of logarithmic laws and exponents. So this is it for this video. I hope you like it, and thank you so much.